So hi everybody, so thanks for having me here today. And today I'm going to talk about my latest work titled What Wi-Fi Probe Requests Can Tell You. So this is the outline of today's presentation. I will start by briefly introducing the different techniques that can be used for count people in different environments. Then I will focus on the probe request method, and I will present you one of the biggest challenge of it. And then I will move to the main contribution of our work. And so how we analyze the behavior of probe requests. And finally, I will give you some insights and some takeaway messages. So, since many years, counting the number of people in different environments is a fundamental aspect, not only for crowd monitoring, so for example during COVID, but also for marketing purposes. So let's think about count the number of people that are moving in a closed environment like a mall or an airport. So nowadays there are different techniques that can be used. So for example, camera, LiDAR, infrared sensor, but also you can use more general device that can sniff Wi-Fi and Bluetooth, and like for example a normal Raspberry. So in the first case, you have devices that are they can work sometimes only in specific environments, and sometimes they are very costly and high computational resource demanding. While in other case, so for the second case, for example for a Raspberry is it's very cheap and very flexible. So let's focus on this second case, and let's focus on Wi-Fi. So in order to do people counting, you can use the so-called probe request messages. So there are specific Wi-Fi management frame that are sent by any smart device that you have in order to connect to a Wi-Fi network. So before connecting to a Wi-Fi network, your device starts sending this probe request in broadcast to start the communication with the access point, let's say the router. So what we can analyze, so what we can use is the source MAC address. So inside the probe request frame, there are a lot of fields, but also the source MAC address. It should be globally unique in the world, but since 2014, 2015, many smartphone vendors, but let's say in general many smart devices vendors, start to implement some randomization technique to, let's say, enhance the privacy of the users. So the main challenge is the randomization, because when a device is starting sending these probe request messages, the device is not using its original MAC address. So for example in this case, it's not using its original MAC address, but every time the device uses a different MAC address. So as our sniffer, let's say if we put a sniffer an access point, every time it will see different probe requests with different MAC address, and so it's not easy to count. And also when the device connects to an access point, it starts using the same, let's say, original MAC address, and we will see later why I'm put in brackets original. But also when the device is connected, it's still searching for other access points. Maybe they have better strength or better quality. So there are some open questions in literature. So for example, how often the MAC address changes, what affect the change of a MAC address, so more in general, what is the behavior of MAC address randomization? And can we still use it for counting the number of devices, so people? So we try to answer all these questions doing some tests. So our test consisted in the analysis of the behavior of probe requests. Practically with a sniffer device, we sniffed the network we use some devices that I will show you later. So, as you can probably imagine, due to the randomization problem, we cannot, we can be sure that we are sniffing a probe request coming from one of our devices only if that device is around the sniffer. Because if there are other devices around, we cannot be sure that that probe request that we capture is coming from our device. So we decided to go in this very wide area in La Mandria Park near Turin in March 2022. It was a very cold and gloomy day, and you can see in the picture on the right, there were nobody around, so we were lucky enough to be sure that we were the only one in the park that day. We use this sniffer device, so it's a Raspberry Pi 02, very low-cost device with an external Wi-Fi card, because the internal one is not allowed to sniff the network, so to put in monitor mode. And also we attach a GSM dongle to be able to communicate between our PC. So here we have the list of devices that we tested. So not only smartphone, but also a tablet and 2 laptops. They are all, we tested also different operating system, so different operating version, newer model, older model, to understand better the behavior. So also what is, every release of operating system means that maybe the vendor, let's say Apple or let's say Android, changed something in the operating system. So we also tested what changed during the different years. And what we analyze, so for example, the MAC address randomization, the sequence number, the RSSI power, SSID field, so all the information that can be used later to count the number of devices, or let's say to mitigate the effect of randomization. So the methodology that we follow. So we divide our experiment in 3 phases. So locked, awake, and active. It means locked means the device was locked, nobody was touching it. Awake means that the device was locked and we just tap on the screen or just press the power button to awake the device. And active phase means that we were using the device and browsing the web or moving around the settings. And we repeat the same 3 phases when the device was connected to an access point. So before it was not connected, and after it was connected to an access point. So here are results. Don't worry, I will zoom in. So I will present you the results of the iPhone 11. So let's zoom in and see. So in the first graph on the top, so first of all, with different color we highlighted the different phases. So here the first phase is in yellow, if you can see from the screen, is the lock phase, followed by the awake phase and then the active phase. And this first half is when the device is not connected to an access point, while in the second half we repeated the same experiment, but the device was connected to an access point. So in the first graph we can see the occurrences of packets that we receive. And as expected, during the lock phase we receive at the beginning some packets, but then they decrease a lot until almost 0. While during awake and active phase we detected a lot of packets, meaning that after some time, when your device is, for example, in your pocket and you are not using it, it start sending less probe requests because maybe the Wi-Fi is not needed. While when you are using it, or when you are awaking it, he starts sending probe requests because, okay, maybe the users wants the Wi-Fi, so let's connect to a Wi-Fi or refreshing the connection. So in the second graph, instead, it's very interesting because you can see in blue the packets received with a random MAC address, and in orange, the one with the original MAC address of the device. And as you can see, there is no orange, meaning that the iPhone 11 is always using a random MAC address, never the original one. So this is the effect of randomization. So Apple worked a lot for enhance your privacy. Let's move on. For example, here you can see in the first graph the SSID. When the device was not connected, we never detect the SSID, so the field was always filled with wildcard, meaning everything. While when the device was connected to an access point, it starts sending also the name of the network it was connected to. And this is also interesting because allow you to think why, for example, in the airport or in the mall there is the free Wi-Fi. Because when you are connected, you are sending more information. Okay, so I will skip this part because I'm running out of time. But if you are interested in reading everything about these results and also about the results of the other smartphone and some newer smartphone that we tested some weeks ago, you can find everything or in the paper, so with the same name of this presentation, or on my GitHub repository, you can find everything. So let's move to some takeaway messages. So, as I showed you before, so the number of packets varies drastically after the connection to an access point. Usually the packets, so the probe request messages are sent in bursts, meaning 2-3 packets with a very short time between each other. After the connection to an access point, the number of distinct MAC addresses decreases. This is because after the connection, usually smartphone or tablet start using the same random MAC address, meaning that the MAC address is still randomized, but it starts using always the same. Because if I'm talking with an access point and I'm connected to this access point, I cannot change my MAC address after some time, otherwise this access point is not able to recognize me again. Okay, so this is why they start using the same MAC address after a connection. And for example, also when the connection is established, the probe request indicate also the SSID. And more important, so for all devices, for example, iPhone 6 from 2014 and the Huawei, they do not implement any randomization techniques. And so if you have this device, pay attention because people can track you very easily. And also we saw very similar results between devices belonging to the same family. So for example, for Apple family, so we saw very similar results between the smartphone, tablet, and the laptop. So the main takeaway message is, even if the MAC address randomization is implemented nowadays in most of devices, it's still possible to use this technique to do people counting or crowd monitoring. So yeah, that's all for me. Thanks for your attention.